Hello Year 5 and welcome to Tuesday's maths lesson, and today we're going to be looking at converting between millimetres and centimetres, so we're starting to look at measure. But we've got a starter today to warm our brains up before we even get into our review, because I want us to remember how to multiply and divide by 10, because this is a really important skill for today's lesson. So because we are on the video, instead of looking at this document on Padlet, this particular page, we're going to look at a PowerPoint together, which is going to help us recap this. So grab a piece of scrap paper or something to write with and write on, and see if you can complete the activities on the PowerPoint with me. Okay, let's get started. So hopefully you remember the Gategno chart. I want us to explore what happens when we times a number by 10. So let's look at 1 times 10. What do you notice? Okay, 1 times 10 is 10. What do we notice when we times 2 by 10? 2 times 10 is 20. I'm going to keep going through them, and I want you to think, what is the rule? What happens in place value when we times a number by 10? What can you remember? Okay, so hopefully you remembered that when we times by 10, we move our digits one place to the left. Okay, it worked each time, didn't it? So let's look at what that looks like on a place value chart. So let's imagine that I've got a counter in my ones column. Okay, I've got ones, tens, hundreds and thousands. Remember though that we have got other place value columns on either side of this. Okay, so let's imagine that this counter is representing 1. What would happen if I times 1 by 10? If I made 1 10 times bigger? Well, 1 times 10 is 10. So I would move my counter into the next column, one place to the left. 10 times 10 is 100. So my counter would move into the hundreds column. 10 times 100 is 1,000. So I would move my digit one place to the left. So every time we're moving one place to the left, we're making the number 10 times the size. Hopefully you remember. Let's look at what that looks like with a digit, okay? So if I make 1 10 times the size, it becomes 10. I would need to show a place value holder here, wouldn't I? To show that I've now got 2 digits instead of 1 digit. 10 times 10 is 100. Again, I'd need my place value holders. 10 times 100 is 1,000. Now let's look at some calculations, okay? You might want to pause the video and have a think about this one. What will happen to our digits? Okay, so let's put 6 in our place value chart. Now to times 6 by 10, we want to make 6 10 times the size. So let's think about 6 and make it 10 times the size. To do that, we move it one place to the left, and we need to put our place value holder in to show that it's 60, okay? So 6 times 10 is 60. Move the digits one place to the left. Now let's look at this with a 2-digit number, just to remind ourselves that it doesn't matter how many digits we've got, we move all of the digits one place to the left, okay, keeping the same combination. So let's put our 12 in the place value chart. Now you might want to pause the video and think about what it's going to be. 12 times 10. Think of 12, make it 10 times the size, move it one place to the left, each digit. We would end up with 120. Okay, so my 1 has moved one place to the left, my 2 has followed, but I still have that same combination, 1 and 2, next to each other. Okay, so remember that we add our place value holders to the end of the number when we're timesing by 10. Now a little activity for you. So hopefully you can see that I've timesed the numbers on the top row by 10 to make the numbers on the bottom row. So I want you to carry this on, okay? Off you go. Okay, how did you get on? So let's go through it together, okay? 10 times 10 is 100. 11 times 10 is 110. 12 times 10 is 120. 13 times 10 is 130. 14 times 10 is 140. 15 times 10 is 150. 16 times 10 is 160. 17 times 10 is 170. 18 times 10 is 180. 19 times 10 is 190, and 20 times 10 is 200. Hopefully you got all of those ones right. Okay, now let's look at the inverse. So we know that timesing by 10, we move the digits one place to the left. Now let's remind ourselves what happens when we divide by 10. Okay, let's explore this. So 1 times 10 is 10. So now let's use the inverse. Let's start with our 10 and divide it by 10. What will we end up with? 1. Okay, and I can think about that. If I had 10 sweets and I divided it into 10 equal groups, there would be 1 in each group, wouldn't there? So 10 divided by 10 is 1. Let's look at another example. So 2 times 10 is 20. Let's look at it in the inverse. So let's start with our 20 and divide it by 10. That will leave us with 2. Okay, read the next one with me. 3 times 10 is 30. So 30 divided by 10 is 3. Okay, I'm just going to click through the rest of them. If you want to pause the video now and have a look at the other ones, please do. Just click ahead. Okay, so hopefully you've noticed that when we times by 10, we move the digits one place to the left, and when we divide by 10, we move all the digits one place to the right. We undo it, don't we? Okay, so let's look at this on a place value chart. And again, you might want to pause the video now, put your 90 in the place value chart and think about what is going to happen to the digits. Okay, so let's put our 90 in. If we are dividing by 10, we're going to move each digit one place to the right. So instead of 9 tens, we end up with 9 ones. 9 ones. Okay. You might think about the 0. We wouldn't need the 0 here because we don't need a place value holder for our tenths column. Okay. So now let's look at another one. Let's look at 3-digit number. So 160. Let's put that in our place value chart. Have a think about what's going to happen to our digits. What is 160 divided by 10? So we're going to move all of our digits one place to the right. We will end up with 16. Okay. Remember that we do have the tenths column and then the hundredths column. So if we had a number like 162, if we had 2 ones there and we divided it by 10, think about what our number would end up as. Well, our 1 would still move one place to the right, and our 6 would move one place to the right. And if we had a 2 here, that would move one place to the right as well. But we need to put our decimal point in. So we'd end up with 16.2. So just remember that this still works for decimals, okay? So again, I want you to have a little go now. So this time I've got the bottom row and I've divided the bottom row numbers by 10 to get the top row. So I want you to carry on this table. You might want to write down the calculations as you go. Pause the video now. Okay, hopefully you got on well with that. So let's go through them. So the next one would be 100 divided by 10 is 10. Then we have 110 divided by 10 is 11. You can join in with me with saying this. 120 divided by 10 is 12. 130 divided by 10 is 13. 140 divided by 10 is 14. 150 divided by 10 is 15. 160 divided by 10 is 16. 170 divided by 10 is 17. 180 divided by 10 is 18. 190 divided by 10 is 19. 200 divided by 10 is 20. Excellent. Well done for completing your starter. Now I want us to go back and look at our learning intention. So we're going to start looking at converting between millimeters and centimeters. And because we're starting our conversions unit, I want you to look at the following conversions. These are really important to memorize. They're going to be so important for you in year 6 and in high school. So recap what the different symbols mean. And what I want you to do is make yourself a quick flashcard set right now using any paper. It could be scrap paper, it could be this PDF if you've got it in front of you. And what I want you to do, on the one side, I want you to write the units, so like 1 kilogram. And then on the back, I want you to write its equivalents, so 1,000 grams. And then you'll be able to test yourself and practice your recall throughout the week. So pause the video now and make some quick flashcards. Okay, so now let's carry on with our lesson. Let's learn. So we're going to look at converting between millimeters and centimeters now. So remind yourself, how many millimeters are there for every centimeter? So Sam drew 3 characters. He drew Spiky, Curly, and Smiley. And he measured their heights in millimeters. So you can see he's got his measuring tape out. What is each one's height in millimeters? Can you measure them now and write that down? Okay, so hopefully you can see that Spiky is 30 millimeters in height. Curly is 35 millimeters in height, slightly more than 30, but lower than 40. And Smiley is 28 millimeters in height because he's less than 30, but greater than 20. Hopefully you got the same as me. Now we know they're millimeters heights, but can we write their heights in centimeters? We're going to think about what we know today to help us do this. So we're going to use I know and so to help us. And I'd encourage you to think about writing that too. Let's start with Spiky. So I know that Spiky is 30 millimeters tall. And I know that 10 millimeters is 1 centimeter. Okay. Let's look at the relationship there. 10 millimeters to 1 centimeter. What's happened to those numbers? Well, I can see that 10 divided by 10 is 1. Okay. So if 10 millimeters is 1 centimeters, 30 millimeters is 3 centimeters. Can you see the relationship? I know 10 millimeters is 1 centimeter, so 30 millimeters is 3 centimeters. 30 is made of 3 lots of 10, isn't it? Okay. Now again, let's look at our relationship here. What's happened to our 30 to get to the 3? We've done 30 divided by 10 is 3. So we know now that Spiky is 3 centimeters tall if he is 30 millimeters tall. 30 divided by 10 is 3. We might be able to generate a rule in a moment, but let's look at another one, okay? Let's look at Curly. Okay, so in order to break Curly's measurement down into centimeters, I'm going to look at his measurement. It's 35 millimeters, isn't it? And I'm going to partition the 35 into 30 millimeters and 5 millimeters to work with those separately. So some of this will be really familiar now. Let's look at the 30 millimeters. So I know 10 millimeters is 1 centimeter. So 30 millimeters has to be 3 centimeters. We know that from before, don't we? So I'm just going to make sure that we've got that already. We already know part of this. 30 millimeters is 3 centimeters. Now let's look at what 5 millimeters would be in centimeters. So we know that we've been dividing our millimeters by 10 to get to our centimeters. So if I start with 1 millimeter now, what would 1 millimeter divided by 10 be? That's an interesting one. So let's remember our place value charts. We'd have our ones, okay, 1 millimeter. Now what's going to happen if I divide my 1 by 10? Remember that when we divide by 10, we move the digits 1 place to the right. So my 1 would end up in the 10ths column. And I'd need to use a placeholder this time to show that I've got no 1s anymore because my 1 has moved to the 10ths column. So let's look at that. 1 divided by 10 is 1/10. Okay, it's the same, isn't it? So if we know that 1 millimeter is 0.1 centimeters, so 5 millimeters, what's it going to be? It would be 0.5 centimeters because 5 divided by 10 is 0.5. If this is going too quickly, then you might want to pause the video, maybe rewind part of it, maybe think this through yourself, because it's really important to think about what's going on here, okay? So now let's put these together. So we know that 30 millimeters is 3 centimeters and 5 millimeters is 0.5 centimeters. So if we put those together, we'd have 3 whole centimeters and 0.5 centimeters. So we would end up with 3.5 centimeters. Now I can see a fast track here, because if I take my 35 millimeters and I divide that by 10, 35 divided by 10 would leave me with 3.5. So instead of breaking it down, perhaps you could start to fast track some of these. Okay, think about dividing your millimeters by 10 to get to your centimeters. So Curly is 3.5 centimeters tall if he is 35 millimeters. Now I think we have generated a rule here. So how will we convert from millimeters to centimeters? See if you can fill in that box. Will we multiply the millimeters by 10 or divide the millimeters by 10? Okay, read it with me. To convert the millimeters to centimeters, divide the millimeters by 10. We'll look at why that is a bit later, okay? Okay, so now let's look at Smiley. You might want to pause the video now and see if you can work out what Smiley's measurement would be in centimeters, thinking through the thought process. Okay, let's go through it together. So I've broken 28 millimeters into 20 millimeters and 8 millimeters to think about it separately. I know that 10 millimeters is 1 centimeter, so 20 millimeters has got to be 2 centimeters. Because if I do 20 divided by 10, I get 2. So now let's look at the 8 millimeters part, and let's start with what 1 millimeter would be. I know that 1 millimeter would be 0.1 centimeters, because 1 divided by 10 is 0.1. So now let's scale that up to 8. If I know that, so 8 millimeters has got to be 0.8 centimeters, because 8 divided by 10 would be 0.8. So let's look at these together, put them back together. So if 20 millimeters is 2 centimeters, and 8 millimeters is 0.8 centimeters, I add my 0.8 to my 2, I would end up with 2.8 centimeters. I wonder if you fast tracked it like this. So 28 millimeters divided by 10 would be 2.8 centimeters. So Smiley is 2.8 centimeters tall. Okay, so our rule, say it with me. To convert millimeters to centimeters, divide the millimeters by 10. Now you might think that that's quite a strange thing, dividing. Okay, I'm just going to show you a ruler here. And I'm going to show you a scale in millimeters. There we go. So you can see here that we've got lots of millimeters. Okay, so we're counting in tens, aren't we? Because between every centimeter, we've got 10 millimeters. So it kind of makes sense that if I want to get to my centimeters, I need to, even though I've got a greater space, I need to end up with a smaller number, because you can see that when we count in centimeters, we're actually just counting in ones instead of tens. So it kind of makes sense that when we are converting from millimeters, we've got more of them, because each one is smaller, we need to divide that amount to get our centimeters, okay? It's a little bit tricky to get your head around, so you might want to take a ruler and look at the difference, okay? We've got more millimeters for every centimetre because they're smaller. Good. Okay, now let's think about this one, a new problem here. So a new character has been drawn, and a new character has a height of 4.2 centimetres. I want you to write the new character's height in millimetres this time. So we're going to go the other way. So pause the video now and have a go at this. Have a think about what you know and what you would do. Okay, so I've split my 4.2 centimetres into 4 centimetres and 0.2 millimetres. I know that 1 centimetre is 10 millimetres, okay? So 4 centimetres would be 40 millimetres. Now what's happening now? To go from our centimetres, which are bigger, so we've got less of them, we want a greater number of millimetres because they're smaller, okay? So let's look at how what happens mathematically. So to get from 1 to 10, we've had to times by 10. 1 times by 10 is 10. So this time we're timesing by 10. 4 centimetres times by 10 would be 40 millimetres. Now let's look at our 0.2. Sorry, put that wrong. I hope you spotted that. Now let's look at our 0.2 centimetres. So I know that 0.1 centimetre would be 1 millimetre, okay? And we know that because we can carry this pattern on, can't we? 0.1 times by 10 would be 1, okay? So let's think about what 0.2 centimetres would be. I know that 0.1 centimetre is 1 millimetre, so 0.2 centimetres is 2 millimetres, because 0.1 times by 10 makes 2. So now let's put these back together. 4 centimetres is 40 millimetres, 0.2 centimetres is 2 millimetres. So how many millimetres do we have altogether? We've got 42 millimetres. And again, we could fast track it, couldn't we? Because if we start with 4.2 and we times by 10, so we move each digit to the left this time, we would end up with 42 millimetres. So the new character is 42 millimetres tall. So what's our rule going to be from converting centimetres to millimetres this time? Have a think. Are we going to divide the centimetres by 10 or multiply the centimetres by 10? Okay, so say the rule with me. To convert centimetres to millimetres, multiply the centimetres by 10. Okay, remember that we're going from a smaller number, which has a greater value, to a larger number, because each one's got a smaller value. Okay. Now, I'd like you to think about some guided practice, which is going to help you develop these skills. We've got the rules here, and hopefully you've got a ruler. If not, you've got paper rulers that you can look back on Padlet and find from previous lessons. Okay, so pause the video now, have a go at questions 1 and 2, and then 3 and 4. Okay, how did you get on? So let's go through the questions now. Now your measurements might be slightly different to me because it depends what size you printed your paper out on. So if you've got slightly different measurements, don't worry, just make sure that you've got that timesing by 10 and dividing by 10 accurate. So I measured line BA. I measured it in millimetres first. So I'll put my millimetres on. And I measured 65 millimetres, okay? And so I need to divide my millimetres by 10 to get to the centimetres because I don't want such big numbers, I want smaller numbers, okay? There are fewer centimetres covering that same amount of space. If I put it into centimetres, you can see here, okay? I need to divide my 65 by 10 to end up with 6.5 centimetres. Now for AT, I'm not going to do all of these, but I ended up with 62 millimetres. So what would that be in centimetres? Let's divide it by 10. It would be 6.2 centimetres. Let's look at TB. I measured 86 millimetres. So what would that be in centimetres? It would be 8.6 centimetres. Super. Now, just a bit of extra practice with our timesing by 10 here. So if I just reveal this, you can self-mark, okay? Now, this is the question that I found interesting. So would these calculations help us convert millimetres to centimetres or centimetres to millimetres? So let's look at what we're starting with here. We're starting with a small number and we're making it 10 times bigger to end up with 50. So I think that we would need to convert our centimetres to millimetres here. If I get my ruler back out, I know that 5 centimetres, there it is the same as 50 millimetres. So I'm converting from my smaller but bigger centimetres to my bigger amount but smaller millimetres. Okay, it's like the opposite, isn't it? Okay, let's look at the next questions. So starting to problem solve, because this is a really important skill. A book is 23 millimetres thick. How thick is it in centimetres? So for this problem, we're converting our millimetres to centimetres. Remember that the picture is just there to help you visualise the problem. You're not going to get your ruler out and measure because it's not to scale. So let's think, how will we convert millimetres to centimetres? We need to divide by 10. So 23 millimetres is 2.3 centimetres because 23 divided by 10 is 2.3. Hopefully you have the same as me. The next question. A red ribbon is 12 centimetres long. A blue ribbon is 12 millimetres longer than the red ribbon. Find the length of the blue ribbon in millimetres. Now I've just noticed that I've revealed all my different bits here, so let me talk it through, okay? So, I might just cover these up because then I can reveal them bit by bit. Sorry, I forgot to cover these up earlier. Okay, so I know that the red ribbon is 12 centimeters long, and I know that the blue ribbon is 12 millimeters longer than the red ribbon. Now remember, this isn't to scale, so this diagram is just to represent the problem, okay? So the blue ribbon is longer than the red ribbon, but I need to find the length of the blue ribbon. So I'll need to add the length of the red ribbon to what I know about the blue ribbon. I know that it's 12 millimeters longer. So I need to think about my 12 centimeters, add my 12 millimeters. Hopefully you can see where I got both of those things from. And I need my answer in millimeters. So I wonder, would I be able to do 12, add 12, and get an answer of 24 millimeters? Maybe pause the video and have a think about that. Would that work? Okay, hopefully you can see that that wouldn't work, because actually if I had 12 centimeters, okay, it's quite a long part of my ruler, isn't it? What would 24 millimeters be? That would only be about 2.4, wouldn't it? It would be smaller. So could I have a great amount of centimeters and add even more to it and then end up with a smaller amount? That wouldn't work, would it? Okay, a part add a part equals a whole, something greater. So we've got to think about making these the same measurement before we actually solve this, okay? So we want our answer in millimeters. I've already got 12 millimeters here, so I need to think about what 12 millimeters is, 12 centimeters, sorry, is, as millimeters. Now I know that to find my millimeters, I need to times my centimeters by 10. So 12 centimeters would be 120 millimeters. Now that I've got both measurements in millimeters, I can add them together. So there's my 120 millimeters, which was my 12 centimeters. I'm now going to add my 12 millimeters, and it should make 132 millimeters altogether. And I can check this. I know that 132 millimeters would be longer than both of these put together. Okay, it's longer than my original amount, isn't it? 13.2 centimeters it would be, so I know that it's longer than my red ribbon. So use your reasoning skills to think about whether an answer is reasonable or not. Now I want you to move on to your independent practice tasks. Okay, there are some different tasks, and then you've got some deeper thinking to do as well. And the answers are at the end, so don't skip ahead. This has been a long lesson, but there's been lots of recap. I hope that you have remembered timesing and dividing by 10, and it's helped you link to converting centimeters and millimeters. I'll see you next time, guys. Bye.